Alright, welcome back to the next module. This module is about the process flow. So in this module, we will see how we can debug our process diagrams. We'll see some logical structures like creating circular paths, which will create loops in our process diagrams, and how we can use collections, loop stages, uh, and decision stages, calculation stages in our process diagrams. We'll see how we can run the process diagram at variable speeds, uh, and how we can break down a process diagram into multiple pages. These pages are arranged hierarchically, or they can be nested where main page remains at the top of the hierarchy. Or we can reference other pages any number of times from one page. Exception is the main page, which cannot be referenced. So let's look at an example of using uh, decision stages. So here we are inside our Blue Prism Studio. So let's drag the end stage a little bit down, and we'll put a decision stage over here, and we'll open its properties by double clicking on it, and we'll rename it to is Z valid, and we'll check the expression that Z should be greater than 0 for it to be valid, and click OK. Now let's link it. So from the calculation stage, the input goes to the decision stage, and let's link this to the end stage, the yes path, and for the no path, I'll take another end stage and link to that as well. Let me rearrange these stages so that I have a good looking process diagram. Now let's reset and run it by pressing F5, and we'll observe which end stage the process diagram ends at. Okay, so we saw it took the yes path, that is valid. Now let's change the calculation stage to do something different. Instead of x into y plus z, I'll change this to z minus x into y, so that z becomes negative. I reset and run it, and now we'll see if it still takes the yes path or this time it takes the no path. So I'll run it, and we saw it took the end for the no path. So let's save it, and I'll say validation decision. Save it and close it. Let's now look at how we can create circular paths in our process diagram. Circular paths are used to create loops, and we create them using some decision stages which control the number of times that circular path has to be executed. So let's demonstrate that by creating a process diagram. So we'll create, this time let me show you another way of creating process. So using this burger icon, when we click on it, we can say create. I'll call this circular path exercises. We need to give a description, but since this is a demo, I'll just leave it blank. Click finish. Open it up by double clicking on it. Let's maximize it. We'll add a data item. Open its properties. I'll name it loop count. Type is number and initial value is 0. I'll add another data item. Open its properties. Call this max loops. Data type is number. Initial value is 5. add a calculation stage, open its properties, and we'll increase the value of loop count by 1. So I drag and drop loop count into expression, add 1 to it, and store the result in loop count. Let me name it increment loop count, hit enter. Now we will add a decision that will compare the loop count with max loops. Open its properties, loop count, is it less than max loops, and I'll name it loop again, hit enter. Now let's link it together. Now I need to loop again back to the increment loop count. How do I do that? If I just move it like this, then the upgoing link will not be visible to me. So we can use these anchor stages to create a different, let me drag it again. Yeah. So this way I can make it take a different path. So this is the yes path, and then for no, move it like this. All right. Let's now see how we can control the speed of debugging. So usually it runs at a normal speed, but we can control that speed to make it debug fast. If we have to debug a lot of stages in a quick period of time, then we would use a fast speed, or if we would have to slow it down, then we would use a slower speed. So here we are in the circular path exercises. We'll increase this number of iterations. So instead of 5, let's make it 20. And we have set the debug speed to be fast. If I reset and run it, we'll see that the debugging happens very quickly, and soon we exit the loop. Let's now change the maximum loops value. So instead of 20, let's make it 100. Reset. We'll run it. We'll pause, and maybe we can modify one of these two values. So let's modify the loop count value. So instead, it's saying it's at the 13th iteration, so let's make it 130. Run it, or maybe we can step over, and it checks this is 131, which is greater than 100, so this should exit the loop. When debugging, we can right click any stage and set that as the next stage to debug. This helps us to debug in any arbitrary manner. So let me show you this. If I reset this and run it again, I'll pause it, and maybe I'll select this end stage, right click, and set this as the next stage. Okay, so now when I will press go, or I press any of these debug buttons, it will continue execution from this particular stage. Though this is the last stage, there's nothing to do after it. Had there been more stages after it, it would have executed those stages from here. So let me press go, and you can see it completed. When you are setting the next stage, it doesn't mean that from the current stage to this next stage, all these stages would be executed. Blue Prism is simply skipping those in between stages. And the same thing applies. You can even like set your next stage to one of the earlier stages, and this would be like replaying the section of the diagram by setting that as your next stage. So it's not that you are fast forwarding or rewinding, but you're simply jumping forward or backward. Let me show you another important thing that helps in debugging, breakpoints. So when we are debugging, we may like to set breakpoints at particular stages in a diagram. For example, here on the decision stage, we may like to set a breakpoint. So we select that decision stage, right click and click on the breakpoint. You can see another option, set breakpoint condition, that has been grayed out. So once we have set the breakpoint, when I right click, I can see it's enabled and I can set a condition for this particular breakpoint. That is break only when certain condition is met. For example, I would like to break, if you don't set it, let me just run it without it. Reset, run. Okay. As soon as it hits the breakpoint, it stops here. Let me reduce the speed, make it normal. Reset, go. And you see it when it hits that breakpoint, the processing stops. Now, uh, to continue processing, we can either press go or dismiss that dialog box. Okay. Now when it hits that decision stage again, we get that breakpoint. If I press go, it continues processing. Okay. Now it's stopping here every time it comes to this stage. So setting a conditional breakpoint is helpful when we want to check something when a certain condition is met. For example, I want to check here when the loop count value is a certain value. Okay, so I'll say when loop count is equal to 10, I would like to do it, check it. So let me validate. It should return me a bool value. Okay, it's valid. Now, if I reset and run it again, let me increase the speed one more time. Run it. It should hit that breakpoint only when loop count value is 10. So once the loop count value is 10, the breakpoint is hit. And if I dismiss this breakpoint now, you can see breakpoint condition loop count is 10. So when I dismiss this, run it again, it will continue running without ever stopping over there. Another thing about breakpoints is that when you have set breakpoints and you run these processes from the control room, though I haven't talked about control rooms yet, that's the place where you will run your processes in the production. So when you're running your processes from the control room in your production environment, there these breakpoints will not have any effect. The breakpoints are hit only when you're running these processes inside your process studio and not outside them. Next, I want to talk about collections and loops. So far we have used data items. Data items, they are used to hold single values in them. What if we have a complex data type? Like we have a data type, like we want to store not just one data type, we have multiple fields in our data and you want to store them together. For that purposes, we have collections. Collections can hold multiple pieces of data together. And you can think of a collection like a tabular value of columns and rows, similar to an Excel spreadsheet. We access each row of data in the collection at a time using the loop stage. So let's have a look at this collection example. So let's set a loop stage to the diagram. It automatically puts a loop end stage. We'll configure this loop start stage by opening it. And here we see a collection drop down. So if I pull down this drop down, I can see my collection, which is my orders. So I'll select that, click OK. So we'll put a node stage in between this loop and we'll connect all of these things together. Since we have 3 rows in our collection, this should iterate thrice. Let's run it. So this is first iteration, second iteration, and third iteration, and then it should end. Okay, completed. We also saw how this text in this collection was changing. Let me show you again. It's row 1 of 3, row 2 of 3, row 3 of 3. Let me now show you how we can use collections in our examples. So continuing with this thing, and what I want to do is in this collection, if I go to initial values, I have these quantities 3, 8, and 5. I would like to add these numbers together. So we'll add a data item. Open it. We'll set its name to be total quantity, and its data type will be number, and we'll set the initial value to be 0. We delete the node stage, put a calculation stage, open its properties. We'll call this add quantities. Now we'll create an expression to calculate the total quantity of items. So to do that, this is my collection. We have the my orders.quantity. You can also find the same field under numbers, my orders.quantity. So drag it from one of these places inside your expression area, and we'll add this to total quantity. Remember, we set this initial value to be 0 and also store it here. So we are taking the current value of quantity in the collection when we are iterating, and we are adding it to the sum that we have calculated so far, and the total sum is added back into total quantity. Let's join all this together and run it. So we get the value 3, it becomes 11, and finally it becomes 16. So let's open up our collection and verify whether the sum is 16. Yes, 3 plus 8, 11, 11 plus 5 is 16. Now let's do one last example where we will find the earliest order date. We will now find the smallest value of order date in our collection. So let's delete this and the calculation stage. We'll make more space by dragging it a bit down. We'll add a data item. We'll call this loop counter. Its data type will be a number, and its initial value would be 0. We'll have one more data item. Its name would be earliest date. Type would be date, and initial value is left blank. Let's have a calculation stage. I'll call this count, and here we will increment the loop counter. So we'll take loop counter, add 1 to it, and store it back into loop counter. We'll have another decision stage. Which I will call first loop, and here we'll check if loop counter is 1. So if it is 1, we are dealing with the first state, and we'll assume that to be the earliest state so far. We'll use a calculation stage to set the value of the earliest state. We call that set earliest state. And my orders dot dot the current order date that we're iterating through becomes our earliest state. If the loop counter is not 1, it means that we have moved past the first row, and now whatever date we are dealing with in the collection, we can compare that with the earliest date that we have stored into our data item. So to do that comparison, we'll add another decision stage, and we'll call this earlier date. So the way that we'll check it, if this is less than the earliest date that we have so far, then we know we have got a new earliest date. So if that is the case, we can use the same calculation stage to set the earliest date. So let's connect these things together. I'll need to switch so that this is the yes path, this is the no path. If this condition is false, then we know that we don't have to modify our earlier state, and we can continue with the next iteration. So let's link this, and notice if I want to move to the next iteration, I don't have to join earlier date with loop start, because that will make the loop to iterate from the first row, which I don't want. I want to iterate from the next row. So I need to join it to the loop end. Let's run this. There is an error. Missing link. Set earliest state. Okay. So let's join this. We'll run it. So it's setting the earliest. The first state is set as the earliest state. Now it checks the second date, which is earlier than the first date. So again it sets it. Then it checks the third date, which is not earlier than the earliest date, and it skips that. So if you notice here in this collection, current values, the earliest date is the second row, which is 26 January 2010. And that's what we see over here. When we are creating Blue Prism workflows, process diagrams, we may not be just containing ourselves to a single page inside the Process Studio. Our process diagram may be large enough to actually split that process into multiple pages. So we can split those pages into a page hierarchy. So to show that, let's open up the circular path exercises. So let's create another page over here. We'll right click this main page tab and click on new. We'll keep this name page 1. Click on OK. Here we'll simply make it a pass through page. It's doing nothing. It will just begin and end. We'll go back to the main page and we'll add a page reference stage. Here it is. Once we drop it, we'll get this wizard. We want to create a reference to an existing page. Next, select the page that you want to call, page 1, finish, and it gets the name of the page that we are calling. So it's page 1. Let's verify that by opening this page stage. And here we can see it's referring to page 1. We'll put it somewhere over here. Let's delete that. And let's run this. So now it should go to page 1, comes back to main page. So whenever it hits the page 1 stage, it goes to page 1 tab, executes it, and returns back to the next stage. So it will do 5 times since we are iterating 5 loops. And it finishes. We can also have nested pages, which is a page within a page. So let's add another new page, and I'll keep the name as page 2. Okay. This also will be a blank page which will not do anything significant. It's just a pass through. And on page 1, we'll now add a call to page 2. So we'll drop a page stage which brings this wizard. We'll reference an existing page, so click next. Here we'll select page 2, finish, and make it part of the workflow. Let's run it one more time. This time maybe I'll reduce the number of iterations to 2 and run it. So it goes to page 1, which then goes to page 2, comes back to page 1, and comes back to main page. Again, page 1 goes to page 2, finishes, goes back to page 1, and that goes back to main page. Let me now show you how we can delete these page references and what happens when we delete them. So we'll delete this page 2 reference by right clicking and clicking on this delete button. Sorry, this delete menu. We'll say yes. Now if we go to page 1 and open the properties for this page reference, we'll see that has been orphaned. We see page that has been set to none. So when you delete a page that has been referenced somewhere, you also need to make sure that you remove those page stages that are referencing to the deleted page. So we'll delete this as well and join it back. So in this module, we saw how we can set the next stage and breakpoints that can be used for stepping through the process. We looked into collections and data items that can hold multiple pieces of data in columns and rows. We also saw how we can control the speed at which we can debug our process diagrams. We saw how we can break up large processes into smaller sections called pages, and these pages are arranged hierarchically or nested, where the main page is at the top of the hierarchy, and a page can be referenced any number of times by other pages.